So welcome to my dear student and learners. So today we are going to learn how to implement RS-485 communication. So RS-485 communication is an industrial specification that defines the electrical interface and physical layer for point-to-point communication of electrical devices. RS-485 standard allows for long cabling distance in electrically noisy environment and can support multiple devices on the same bus. This is the thing. Say this in this communication, the cabling length can support up to 1200 meters also. So the sensors which are at long distance and the sensor output should be taken to host controller or the local controller which is at long distance, but the environment is slightly noisy. There will be a significant electromagnetic interference. So if you use directly the analog output from the sensor, then during transmission the noise can be mixed up and you may not be able to get the actual physical parameter reading. In such case, if you are locally at the sensor end, at the remote end, if you convert the signal digitally and transmit, it will be better. So for that purpose only this RS-485 standard is evolved. So here we will learn first the connection. So what we are going to do here, basically there will be a IR infrared sensor. So this is that infrared sensor. So one LED is working as a transmitter, another is receiver. So if in front of these two LED, if there is no object, so the infrared which will be transmitted by the transmitter will not be reflected back. But if there is any object, then the IR, it will be reflected by the object and it will be incident on a receiver LED and it will be sensed. So here you see there are three pins. One is, this is the VCC, this is the ground, and this is the signal output. So normally if there is no object detected, so the output pin will be high. Here we are using 5 volt logic. So if there is no object in front of these two LED, then the output you will get as 5 volt. And if there is any object detected, then that output value will be dropped to 0 volt. So the connection here we are using Atmega 328, that is in Arduino Nano. So you see this VCC is connected to 5 volt and the ground is connected to the Nano ground, and the signal output, the IR sensor signal output, it is connected to pin number 2. This is the connection. So this, now whatever data we will be receiving, that will be transmitted through RS-485 protocol. So this is the circuit for, this is the device for RS-485 converter, which used MAX 4851 IC. This device is readily available in the market. So there are in the left side, you see there are 4 pins: RO, RE, DE and DI. So this RO pin, basically it is the receiver pin, and DI it is the transmitter pin, and RE is receive enable, which is at active low state, and D is the transmit enable, which is active high state. That means if you want to initiate the transmission of data, then definitely this DE pin is to be make high, and if you want to receive data, then that RE pin it is to be made low. So what I did here, you see here, at a time I want to do either transmission or to receive the data. So that's why I shorted this RE and D, and I have given one pin D3. So through this D3 I will be controlling this device, whether it will be used for transmission or whether it will be used to receive data. So if I make this D3 pin, this is connected to D3, if I make this D3 pin high, then this device will transmit the data, and if I make, and that time this will be in opposite logic, it will be toggled, so there will be no receiving. So similarly, if I made this pin D3 low, then this device will act as a receiver, and similarly this DE pin, it will go low, so it will not transmit anything. So for that purpose I shorted this two pin. Otherwise you can individually also connect the pin, but here at a time either we want to receive or transmit, so that's why I shorted and connected to a control pin. And this RO pin, this yellow color line, it is connected to, as I told, it is receiver, so it is microcontroller receiver pin. You see here it is connected, and the DI, that is the transmission pin, transmitter pin, transmit pin, so it is connected to TX, or transmitter of the microcontroller. So this side connection is over. Now in the right hand side here, 4 terminals are there. This one is the VCC. So here it will, all we are using 5 volt logic. So again this point is connected to this terminal is connected to the 5 volt of the microcontroller, and this is the ground pin. The last one, it is connected to the ground of the microcontroller. And this A and B, these are the two lines. Once the data is converted digitally, the conversion is completed, then through this two line the data will be transmitted, and the cable, this cable distance, this two cable, the distance can go up to, as I told already, 1200 meters also. So the entire circuit, this entire 3 devices will be remote end, where the sensor is kept. It is at long distance. So there these three devices will be kept, and from there only this 2 wire, it will be connected to the local or the control station. So this entire circuit I told, I named as remote end master circuit. It's a master slave topology we are going to use. So this will be a remote end master circuit. Okay, so hope the connection is clear. Now I am coming to the code. So this code will be, this master code, it will be uploaded to this board. Okay, and this microcontroller should be powered up through this cable. It is to be powered up. Okay, so now the code is, I am defining the data transmit pin, as I told, it is connected to pin 3, so this one. And if you see the drawing, the output, the sensor output is connected to D2, so that's why the this IR sensor output at pin 2. And I am defining the pin mode, so the LDR sensor out, so which is taken as a input of the microcontroller, so that's why it is defined as input. And the data transmit enable pin, as I told, we want to transmit the data from the remote end, we want to transmit the data, so you need to control it. Sometimes we need to make high or low, so that's why it is made, it is initialized at as output, and we are initializing the serial communication with a baud rate of 9600. Then we are making it as low, so that always it is better to initialize the pin before starting the transmission. So that's why it is made at low, as low. Okay. Now, as I told, to initiate the transmission, we need to make this pin, the pin 3, high. So that's why you see, before starting the transmission, I made this as high. Now the device is ready to, once it is high, now the device is ready to transmit the data. And why I given a delay? Because it will take the transition, during the transition, even though you know this will be like this, but actually it is not like that. The transition from low to high will happen like this, we think ideally, but it is not like that. It will slightly delay, it will take place. So this delay. So to avoid this effect, I am giving a delay of 5 millisecond, so that now the pin is completely high. So once the pin is high, now my RS-485, that MAX 485 device is ready to transmit the data. So what I told, in the sensor is connected to pin number 2. So if the pin number 2 is high, then I am sending one string A0. So here this addressing you can, because here we are going to, finally we are going to implement 4 sensors which will be connected in a host microcontroller, and that host microcontroller, it will be connected to a laptop. This is the PC where we can see the status, whether any object is detected or not in the 4 sensors. Okay. So if there is no object detected, as I told, then always the output pin will be high, and that time we are transmitting, we are writing a string A0. Similarly, if the object is detected, then the sensor output will go high to low, and that time we are sending one character A1. Okay, and this, after that I am writing serial.flash, means this command is that the complete, that the writing of the in the serial port is over. So for that only I am writing this, and once it is over, then I am disabling. Again I am making it low, means I am stopping the transmission and giving a sufficient delay of ½ second, that entire operation can take place nicely. So this code will be uploaded to this master board, and the connection will be done as shown in the picture, and this microcontroller will be powered up using the cable, using the power cable. And now this RS-485, this A and B terminal will be connected through a long wire which can go up to 1.2 kilometer also. Now that output, means this 2 wire, it will be traveling the desired distance, and it will be connected to another RS-485 device which is placed at local end, where the control and the receiving systems are placed. Okay, now all other connections are same. Okay, all other connections are same. Now whatever data it is sent by the, you see there, you remember there we are sending A0 and A1. A0 is if the object is not detected, and A1 when the object will be detected. That we are going to receive here. the distance is more. Okay, so this circuit I named as local end slave circuit. So now I am coming to the code. This code also very simple. So as I told, when this device I will be using as receiver, then definitely this pin, this RE pin should be low, then only it will receive the data. So that's why this data receive pin I am making as initializing as output. This line is initiating the serial communication, and I am making this pin as low, so always it will be receiving the data. Then coming to the while one loop, inside that I am writing while serial dot available is true. That means if there is no data, then it will not execute anything. But if there is any data, then it will enter inside this while loop. And as I told, if serial dot read, if the data received in the receiver is A0, then we are going to print serial dot println no object detected. And if the serial port received a data A1, that means some object is detected. So this code is to be uploaded in this controller, and this controller will be connected to your laptop to see the status. Now in the remote end controller, if you place any object here, then you can see the result here in the serial port. So hope this is a very simple concept of end-to-end communication using RS-485 protocol. So in the first slides here you have seen the generalized connection. So here you can use so many slave device, and you can use some decoder or multiplexer, that which device you can call, which device you can enable. That means the master can enable one slave device and get the data. After some instant, the next device it will be enabled and take the data. Like that way you can design your own protocol. Okay, so this is a simple thing. So first you make, in summary, first you make this circuit, and from this after making this circuit, you upload this code in this microcontroller, then power this, you give a power to this microcontroller, and then these two wires you connected with the, this is the local end slave device. In that you connect that two wire here and upload this code to this controller, and this controller you connect to your laptop or PC and see the serial, open the serial port and place some object in front of the sensor which is kept at long distance. Then you can see the status. It will be printing whether object detected or not. Object detected means it will print no object detected. If there is no object, it will print no object detected. So this is a simple thing to understand the master slave mode RS-485 communication. Hope it will be useful to you all. Now I will request the three groups. So here only in this course there are three groups. One is this Swati and Sri. So you should show me these things, the output, and Nitin also should show me the output, and the SRM other group, that Shashank, you also, the three group can show me the output individually. Then we will integrate 4 sensors together, and it will connect to the host microcontroller that will be connected to the laptop, where the Python GUI it will be interfaced. So that Python GUI part is already done. Okay, so please do it as early as possible and show me. Thank you so much. Thanks for your patience.